Okay, so in this video, I'm going to do a couple of the problems that I assigned to you. Um, you have a graph given to you, and notice that there's no lines at the end here to indicate that they go on forever. So in this particular problem, the domain and range will be truncated, so it will be ended somewhere. So first thing you got to understand is the units. We see that it's going up by 1 unit to like one piece here is just 1 unit as well as this way. So we have these half units as well. All right, so the domain is the same way. If I can ask you about an x value and you can give me an ordered pair on the line, then it's part of the domain. So x equals 1, there's a point. 2, there's a point. -2, -2.5, there's a point. So the domain here would be all the values that are shown on this graph, since we do not have something that looks like that. So when you don't have that at the end, it doesn't go forever. So the domain there you can see that it goes to the end here, which is going to be -4.5. That's the smallest. And 4.5 is going to be the largest. So in interval notation, we could do that. And it's included. Both of those values are included. All right, the range would be the same thing that we do in other situations here. If you notice y equals 1, there's an ordered pair. Y equals a half would be an ordered pair. Y equals 2 would be an ordered pair here. So we're going to have to guess on this one because a little bit above 2 there's something, but we don't know exactly what that is. So let's get the lowest y value that we could get. The lowest y value would be right here, and again we're going to have to guess on those. Maybe -0.1. So we have -0.1. We know that it's not more than, it doesn't go past a -0.5, so we'll just do -0.1, and then we'll go to maybe 2.1 for the y value, and we include both of those. Okay, so again, this might vary on people's papers as we go through here, as you have to guess, but as long as it's logical. If you would have put -0.6, well, you couldn't have counted that because we know that it doesn't dip down below -0.5 there. Okay, so now this may vary for everybody's. It shouldn't vary on this one since I'm doing it with you, but the relative minimum is going to be a low point in the graph. So the minimum value would occur right here. And since we know that the end value of the x is -4.5, this would be an ordered pair, -4.5, comma, and then we said that this value was the lowest. So this is an ordered pair. This is not an interval. That's an ordered pair. These are interval notation. Just want to make that known that we have intervals and ordered pairs going on here. The relative max would be this point right here, and using the same logic, we said 4.5 was the biggest x value, and then we said 2.1 was the largest y value. All right, now on what intervals is the graph increasing? So as I look at this graph, from left to right, like I'm reading left to right, what is my graph doing? So as I move from left to right, this function is going up. So it is increasing, and these are going to be an interval, and it's going to be the x values. Okay, so the x values where it's increasing would be from -4.5 and then to +4.5. Okay, there's some books that do include -4.5 and 4.5 in the increasing decreasing. There's some books that wouldn't, so you can either put brackets or parentheses here, it doesn't matter. For this purpose, I'm going to just put brackets. Okay, is it decreasing anywhere? So if I move from left to right, is my pen ever going to go down? No, so we can leave this blank. Constant would mean that it stays horizontal for a while. And here, nothing stays horizontal, so there's no constant. A 0 is where it crosses the x-axis. So if I look at where it crosses the x-axis, it looks like this is the only point. And that point would be -4. You can just state -4 because -4 is a 0. The ordered pair that would go with that is -4, 0. So again, you can just put -4 since it's just asking you to state the zeros. Okay, and again, remember the difference in the ordered pairs and the interval notation. Okay, I want to do number 3 with you. Okay, so same concept as before. The domain, again, these are not going to be exactly perfect. There's no lines here, okay? Unless it tells you that in the problem to act like it goes on forever. I don't think it did. It didn't tell you to do that. So we're good to just kind of guess with that. So the domain looks like any x value. If I ask you x equals 1, well, we're not going to get 1 because the graph doesn't exist there. It would exist at x equals 2. There's an ordered pair. And we know that it would exist way down here. So that's the last x value. Let's guess that that's 1.5. So the domain is 1.5. That's the lowest x value we could have. And then if I go to 3, there's an ordered pair. 3.5, there's an ordered pair. 4, there's an ordered pair. And then the last one would be about right here. And maybe we say that's about 4.5 as well. Maybe that's being a little generous, but so 4.5, and it would include both of those values. Now let's discuss the range. The range is the same concept as before. Y equals 1, I would have 2 ordered pairs. Y equals -1, I would have 2 ordered pairs. Y equals 3, 2 ordered pairs. Y equals maybe 4.5, or excuse me, 5 maybe. I would have 2, so maybe -5, excuse me. -5 would be the smallest y value. And what the tallest y value would be 2. So my smallest y value would be -5. And then I would go up to 2. It includes both of those. Even though I don't have like dots there, since there is a graph there and it's solid, then I'm good to say that, oh yes, it's included. Okay, all right. Relative minimum would be the lowest value that I could get. Actually, on this one, you could state that these are relative minimums because they are the lowest points on the graph and the graph ends. So relative minimum would occur at, now you got to take into consideration what you guessed up here. So 1.5, -5. And there would also be one at 4.5, -5. Again, these are ordered pairs. And these are intervals. I want to make sure you understand the difference there. Relative max would be a point that is at the peak, and this would be that point, and that point would be 3, 2. Again, that's an ordered pair. Now let's talk about increasing. Remember, these intervals are going to be the x values. So where is it increasing? As I move from left to right, I'm looking for the places where it's going up. So as I move from left to right, I would go here. Definitely going up as I go left to right. And right there is where I stop, and then I start going down. So right here is where it stops increasing. So x values would be 1.5 to the x value of 3. Now I would put a bracket there, and I would put an open thing here. Again, books do this a little bit different. I would put an open at 3 because I know at 3 it's going to start decreasing. And my thought process there is it can't increase and decrease at 3. So I'm going to put a 3 for decreasing because at 3 it starts going down and it goes down until we get to the x value of 4.5. Again, I would include that, but I would not include the 3 because if I included the 3 up here, it couldn't decrease down here. I don't think it's increasing or decreasing at all there. Okay, is any place on this graph constant? No, because I don't have any places where it goes here. Now I could argue maybe at this point, maybe at a slight point it's going constant, and we can go over that in class. But I'm okay with you leaving that as blank for right now. Zeros would be where it crosses the x-axis, let's say here and here, and let's just give a guess, maybe 2.2, and maybe that is 3.8. This is not an ordered pair, this is just a list of x values. The ordered pair would be 2.2, 0 and 3.8, 0. Okay, so make sure you can do the rest of those on the homework pack.